Welcome everybody to our last session before the summer holidays. And I am very happy to be here today with Peter, one of our founders from Cybus, and he's also our CEO. Welcome, Peter, and thank you for being here today. My name is Garrett. I'm the event manager here at Cybus, and I will host you through today's session with Peter. And so let's get started right away. We already have a bunch of people online, so I think we can start already. And we do have a quick look at what today's topic, of course, is. So Peter will be talking about the standardization from blueprint to global scale. But before we dive into our first industrial leadership series with Peter, we have a little check-in question prepared for you. And I would just like we would like to ask you just a short icebreaker question, because the holidays are in front of us, the summer holidays, and where are you heading to? Of course, this is something relative easy, so please take part if you can. So are you heading towards the north of Germany or Scandinavia, or simply the North Sea, where Peter will be heading to, going south of Germany, south of Europe, or others? If you want to share, you can feel free to write in the box. Oh, we see somebody's going to Scotland here. Nice for a summer trip. So I think everybody has voted. So you can see the most of you are heading south, as the summer is always predicting. I hope you're not going too far south where you will get the extreme heat up to 40 degrees. So please prepare when heading to those countries that have the extreme heat. But thank you again for participating, and I will now hand over to Peter, and he will share his topic today with us. So Peter, here you go.
Okay, thanks Garrett, and also for this little icebreaker. I think having your mind set a little bit for the hopefully upcoming vacation is pretty nice on the Tuesday. So thanks a lot for joining. This is a format we are trying for the first time. We try to make it as interactive as possible. So please really write your questions that come up in the chat so we can react on that and deep dive into the topics that are of interest also for you. From standardization to global scale, this is a big question many of our customers are facing. I think the term Industry 4.0 has been coined in 2011, so 14 years ago. And still today, whenever I'm talking to customers, everybody is basically saying similar things. It's pretty clear what can be done with data. Many pilots have been conducted. Many use cases have been thought about. Much technology has been tried out. Some have already moved to the cloud, some not. Some already have made experiences with AI, some not. But the overall question, how can we actually bring this into a whole system, a smart factory that works as a smart factory, and how can we scale that globally from site to site? That is really driving everybody around, because it's a really hard question. It requires to rethink how we look at the factory. And I'd like to really deep dive into how we view this and how we've experienced this can be solved. So first of all, without foundation, everything falls apart. So whatever you're planning, and digital transformation, any transformation, is a huge endeavor. You need the right foundation to really be very strong in your strategy and be able to try out different things. The biggest challenge we've found is that there is not only one challenge. As a factory is an incredibly complex beast, and there is not a single use case for digitization, no matter if you are looking at energy management and machine uptime optimization, into AI. When you look use case by use case, and you try to solve use case by use case, you really risk ending up with another extreme of the anyway already existing shadow IT. That's something we've seen quite a lot happening, because every use case has been started as an individual project with an individual technology stack, which was really selected carefully for this specific use case. quickly these pilots start to scale and nobody really knows how to take the governance about that. Additionally, we already have a legacy IT in most factories. Most factories have grown over the last decades with different software systems installed for specific use cases or specific applications, be it your MES, big one, be it a specific database just for quality management, be it a database that just came along with a machine that you just recently purchased. There's a lot of different software systems playing in a factory, but not necessarily playing together. In addition, a lot of regulation is coming up. CSRD, the EU AI Act, the digital product passport, so require you to actually take control over data. And last but not least, and this is often forgotten in the first place when thinking about that, cybersecurity is a huge topic. So when connecting everything in the factory, you must not increase your attack surface, because you probably read the news how many manufacturers suffer from hacker attacks, from ransomware attacks. And I really have heard in the last decade of many, even large manufacturers with large serious IT teams that have suffered from long-term production interruptions just because the cybersecurity on the shop floor didn't work out. So this is the overall challenge. And if you look at this, there's so much you have to think about. And if you think about every single aspect individually without seeing the whole picture, digital transformation really can appear too expensive, too risky, and too slow. So how can we solve that? We can solve that by defining a standard technology stack that once and for all of your sites solves these problems as far as possible and provides a platform where you can put on the individual use cases without redefining the technology stack every time, without having the risk of a new cybersecurity breach with every new project, and just really accelerating instead of slowing you down. But if you standardize everything, so if you define one standard technology stack for all your sites, and your sites might be very different, you might have sites that are highly automated and others that are basically doing manual assembly. You might have sites that are doing electronics manufacturing and others that are more into blow molding, for example. How can you standardize without killing the flexibility? So let's deep dive into this. I'm an engineer and I try to simplify and sometimes oversimplify things. So let's oversimplify the challenges of factories in general. If you ask me, there are exactly two simple categories in which you can put most of the challenges a factory has. The first one is efficiency. Efficiency of any sorts. Am I not wasting material? Am I not wasting energy? Are my machines and my production lines running at maximum output? Am I not wasting manpower or knowledge? Am I not wasting time? All of this can be put into efficiency, and we know increasing efficiency means increasing the margins, and it means increasing the profitability of the whole company. So this is, of course, a primary goal of most projects we are conducting. The second thing is flexibility. Why is flexibility so important? Not only because the batch size one goal, but also because the world seems to turn faster and faster in all aspects. Both the geopolitical changes that we are seeing in the world currently, tariffs, wars, supply chain changes, globalization or decoupling, or a ship that blocks the Suez Channel, everything requires the ability to react, but also the technology that is developing faster and faster. And recently with AI, that shows very clearly that we need to be able to somehow incorporate and integrate these new technologies quickly into our existing factories. So let's look at a very simplified factory. Here on the lower end of the slide, different boxes representing different production lines, but also the intralogistic might be AGVs already. Your building, that's also something you may not forget. So the building automation, air conditioning, the energy system, the heating. So everything, all the assets on the shop floor that make your factory. And on the upper end of the slide, you see the different IT systems that are probably already in play. Your MES, the quality assurance system, your new analytics in the cloud, the building automation system, the different dashboards, maybe already or very soon AI agents. So everything somehow has to talk to each other. And then when I listen to talks or to presentation or talk to customers, many people quickly say the biggest problem is data silos. And I would argue that is not the biggest problem. The biggest problem is a data mess. Why is that? It's not hard to connect things. It's actually today very easy to connect the shop floor to the IT. It's so easy that every working student can connect a machine to a dashboard with open source technology basically within an afternoon. It's not hard. And has become so easy that many factories, or actually most, if not all factories, suffer from an unmanageable complexity of interconnected systems. So how can you keep an overview about which assets are connected to which IT systems? How can you guarantee in such an architecture data consistency? How can you guarantee cybersecurity because you don't know which system is connected to which other system? How can you guarantee business continuity? Because how would you know whenever you cut one of this connection, which of the processes would fail? And last but not least, how can you either replace or add a new IT system, or let's call it use case, to this overall system? How many integrations would you have to redo? This is risk, this is attack surface, and this is cost. And in the end, technical debt. So how can we solve this? Again, I oversimplify. And in my oversimplified worldview, let's fight efficiency problems with data-driven decisions. You can only manage what you can measure, very simple. And let's solve the flexibility challenge with agility. So I know agility sometimes is a trigger word for some people because agile might be synonym to chaos to some people, but I would argue that both efficiency and flexibility are the big challenges that the software world, so really the big software players, especially in the cloud world, have already solved for themselves. So being required to quickly deploy updates and to quickly react and to all the time optimize the experience for the users based on data. So really and that is my first call for action, let's try to learn from this industry, from the software industry, because they have already accomplished managing very complex systems with a lot of control. So this is my very simple statement. Real smart factories are designed and operated pretty much like software. What does it mean? I would say, first of all, software systems are designed for continuous innovation. Let me give you one example for what I mean with that. Just think back a couple of years, 10 years maybe, or 15, when you still needed to install and download, or probably even with a CD-ROM or floppy disk, software updates whenever you wanted a new version of a software on your computer. How often did that happen? Maybe once a year, maybe twice a year? Compared to this nowadays, Look at your smartphone. How often do you install software updates? Never. Except if you have set it up specifically like this, but usually all the apps on your phone and even the websites you visit every day just change continuously in tiny increments. Sometimes you even don't notice it because the vendor has just fixed a bug or improved a little process in the back end. Sometimes you realize it because a new button has appeared or something has moved, but step by step, all the software is evolving. And this is because the software developers have set up a delivery system that allows continuous innovation and continuous deployment of new software versions to your phone without interrupting your experience at all. So just think about how can we apply that to a factory? What if changing software in your production wouldn't require a production interruption or waiting for the summer break, but you could just every day deploy tiny little updates, tiny little improvements in small increments to your production and continuously optimize your processes. Why is it so important to have it tiny? Because sometimes you will make a mistake. Sometimes you will deploy an update that actually makes things worse. But if the steps and the increments and the changes are small, then it's easy to roll them back. From a technology perspective, continuous innovation requires you to set up your overall system so that it's possible to deploy updates at very low cost. This low cost is really the key. So look at your IT setup and think about what does it cost in terms of time, in terms of people involved to deploy a change. And if you minimize the cost to almost zero, then you are very close to continuous innovation. That's what the software world is doing. Second, maximum automation. Again, let's take an analogy. If I'm an IT guy from some big company and I get a task to install a new virus scanner to 5,000 laptops from my colleagues, what do? 20 years ago, I would have taken a USB stick or again a CD-ROM and walked from computer to computer. Nowadays, this is just the press of a button because I have a big, fully automated pipeline that just does it automatically. Now again, think about how are changes made in your shop floor. Typically, you have a legacy software stack, which is not automatable. And you would walk from computer to computer, from PLC to PLC, from industrial PC to industrial PC, maybe from gateway to gateway, and set up new connections. This is exactly what creates cost in change. And this low automation inhibits you in achieving continuous innovation. And the third factor, data-driven optimization, of course, every single small online shop nowadays knows exactly how many users were there yesterday, how many visitors did I have, how many shopping carts have been filled, and then how many actual transactions have been completed. And with just these three numbers, an online shop can just optimize the user experience, optimize the article descriptions, optimize maybe the Google results and so on, and just try to optimize the factors. How much do you actually know about the detailed process data in your factory? Most manufacturers know surprisingly little, and without knowing anything, you don't even know where to start optimizing. So knowing the unknowns, become a data-driven organization and continuously innovate on the data with maximum automation at lowest costs. This is what gives you a smart factory in the end. And in order to accomplish that, you have to get rid of this connectivity chaos into a platform approach. And of course, I'm the CEO of Cybus, so I said I have put Cybus in the middle here because that's exactly what we offer. We offer you the backbone, we offer you the platform for managing your data at largest scale and lowest cost, at maximum flexibility and maximum automation. But I'm also humble and I'm also honest. You can, of course, achieve a similar setup also with different tools, with different technology. But this is the best practice. You have to master your connectivity. You have to master your data. That's the only foundation that you need. And without this foundation, it's impossible to really optimize the factory to the max. So speaking again about Cybus, how does it work in practice? Why can we provide this maximum automation at such low cost? Because we've learned again from IT and we've learned again from how big scalable software systems are managed. IT automation today starts in a repository which allows versioning of complex configuration. So you have different versions that you can keep track of, that you can audit. It starts with processes that that guarantee the peer review of changes before they are deployed, maybe even staging and testing systems. And a pipeline that, with the press of a button, rolls out a complete change to a full factory or even to all sites globally. That means Cybus Connectware is an IT/OT integration platform that allows managing data at large complexity. And it allows to template use cases that are successful in one site and copy and paste that basically fully automatically to all the other factories. If the factories are a little bit different, you can parameterize the templates and adapt accordingly. But the important thing is you always keep track and you never lose the overview and the governance about the data complexity. I won't dive any deeper into technology today. If you are interested in this, please contact us. But this, on a high-level view, Cybus allows IT processes and software deployment processes for managing data at large scale in factories. So how can you generate value from that? This was a lot of theory, this was a lot of high level, this was maybe a little bit technical, but how does it convert into actual savings and actual money? So we find that all the use cases that all our customers are implementing can be basically put into one of three clusters or buckets. It's either integrate, that means our customers are really looking at the smart factory from an IT integration perspective. They're looking at the enterprise IT architecture, and trying to consolidate IT systems and minimizing basically IT project costs. When you get rid of customization, you increase your agility. And that means you can easily integrate AI assistants, a new MES. Many customers currently have to move the MES from on-premise to the cloud. Some just want to implement a unified namespace where they can start working with the data on. It could be a complete greenfield factory, it could be data analytics, or something fancy like a connected worker use case. Other customers are not looking at integration. They are looking at traceability. That means they focus on the product in the production process. This is sometimes for compliance because they have to, for example, in a safety critical environment, or it is for improving the quality and the calculation of the costs that are involved in production. So that could be carbon footprint, so really product carbon footprint use cases, could be track and trace, it could be the digital product passport, things like that. And the third bucket is operation. So we have customers that only look at how can I get more output with the same production line and the same people, or even sometimes fewer people, unfortunately, because getting people into the factories nowadays is not that easy anymore either. So how can we improve the operation of the equipment? That means looking at OEE, looking at reducing the response time of the maintenance team, so quicker resolved issues. Maybe it's just automation of the parameters. So one of the three buckets typically is the use case. Garrett, do we have a question?
No, I'm here for the next slide.
Very good. We have a question.
Yeah, of course. Now that Peter presented you those three options, we of course are interested in, where are we now? In your topic. I need to close this and open the new one. Here we are. Which of these focus areas is currently most relevant in your organization or with you? So please vote here. Which ones are you mostly interested in or are you looking into? And if you're not looking into those or have others or all of those or two of those, you can always type in the chat box so that we can talk about this as well. So I will leave this for a couple seconds here for you to choose your option. So integrate, reducing IT complexity, trace, improving product quality, operate, getting more out of your machines, or others, please type into chat box. So we see a lot of movement here at the moment. Nothing happening anymore. So I think, oh, there we go. Somebody's still looking into this. Yeah, getting more response here. And I think we have reached the finals.
So we have reached a winner. It's operate. And that makes perfect sense because operate very often is the first step. Understanding how the machines run can already save you a lot of costs, and I have some really great use cases for that to share. So thanks, Garrett. Just looking at integrate, we just recently have completed a project where a battery cell manufacturer built a factory basically from scratch to start of production in just 6 months with a fully integrated IT based on Cybus without any customization, a lot of cloud involved, no local data center even. And this was a very successful project, very smooth. And you know how complex IT can be sometimes in greenfield projects, right? Another company, a customer of us, is currently rolling out 15 factories, all very brownfield, very different to the standardized technology stack. And also here with a high degree of automation. And in our calculations, they're saving at least 6 million euro in IT consulting costs compared to other solutions because they are using Cybus. That means they spend some time on building their templates for the first site. So I think they took 4 or 5 or 6 months for the first site, and now they are deploying the same templates, just one per month to all the other factories. So this really increases the speed a lot for the digital transformation, of course. For traceability, we have 2 very interesting success stories. One is of our customers who's a sports car OEM, who's basically tracing all the welding spots, all the screw torque curves even on the car body using Cybus, which is first of all, of course, an obligation. It's a safety critical aspect that needs to be monitored and stored, but it's also improving the processes because you can really find problems pretty quick and react to the root cause if you have a detailed tracing of every single small production step, be it manual, so like screwing, it's a manual workup process with an Atlas Copco screw, smart torque wrench, or if it's automatic, like a welding robot. Another customer of us, industrial metal producer, reduced their scrap rate from 10% to 0 because they introduced detailed end-to-end traceability, which allowed them to early on spot where exactly the production line would run out of tolerance. And that not only helped them solve the issue, but it allows them to react live and avoid that this happens at all. And just looking at operations, we have success stories with customers that are saving literally a full FTE in their maintenance team just because of automatic machine status monitoring. It sounds so simple, but if you have a complex factory, you usually have a little bit of additional maintenance capacity always on standby, because you never know what happens. And if you understand better what happens, and if you have a more automatic monitoring of your machine status, you can decrease this uncertainty factor, and thereby really save full FTEs in the maintenance, which immediately saves a lot of costs per shift. And the last but not least, also a very successful project we've done on energy management. Do you actually know where your electricity is used? Most don't. Also, a customer of us didn't, and they wanted to save energy. They set out with a plan to save 15% of energy when the energy costs rise so much in the recent years. It was shrunk. And in the end, they were even able to cut down 22% of the yearly energy costs, which is almost 900,000 euro savings just from a very simple project that didn't cost them even 6 digits. So it was a very successful, very slim project, just an additional use case on an existing smart factories. And things like that happen every day. And I'm pretty sure there are potentials for such savings in almost every single factory. And no matter where you start, so no matter which of these 3 buckets is your starting point, a smart factory usually covers all of these. So that means if you do it right, if you find the right strategy and the right foundation, then no matter where you start, you end up being able to scale horizontally, to add on more use cases quickly, to really enable the next project, and to simplify your IT without introducing a new shadow IT component with every single project. So I started with a question: does standardization kill flexibility? No. I would say if you do it right, so if you see standardization not like the hammer to every nail, but standardization as a foundation, then you are actually enabling flexibility. And last but not least, and this is the final aspect I want to share before I'm really looking forward to your questions. Last but not least, we can talk about technology. We can talk about perspectives and maybe mindset and strategy. But you also have to look at organization and people. So without clear responsibilities, and this is clearly a question between OT or IT, without clear responsibilities, every project will fail. This starts on the board. So I've seen many companies really struggle already with the question: if it is a CDO or is a CIO or the COO who is responsible for digitization. I'm not here to give a clear answer on that, but I think one very clear statement is they have to agree on a strategy. So if the CIO and the COO, this is the most important combination, the CIO and COO are not fully in sync and agree on a strategy and agree on priorities when it comes to making the organization data-driven, you can forget everything else, because it won't work, because you won't have the budgets, you won't have the alignment, you will have, and I've seen that a lot, you will have fights and competing departments. So this is the first thing that really needs to be set right. So if you ask me, it's a CEO's responsibility to make sure that his board of C-levels is aligned. Very often we also found that the next step is building a center of excellence, a cross-functional team consisting of representatives of automation, of production management, of quality assurance. Quality assurance is very often a very simple way, when you include them, of saving costs quickly, because they exactly know where you waste anything. You also need to integrate the IT from the beginning. Otherwise, they will be your enemy, and just don't open the firewall. IT is your enabler. IT can provide speed if you involve them early on. And of course, you need full management buy-in, because in the first iteration, you probably have to do an investment. The next thing is you need a data strategy. And this data strategy also needs to be aligned within the organization. That needs a governance model. So who is responsible for keeping the overview? You need a plan how you can scale that. Next step, build an architecture, an enterprise architecture. And most probably, don't do it alone. I'm not here for selling consultancy because we don't provide consultancy, but make use of consultants. There's so many, no matter if it's, I'm just dropping a few names, if it's Capgemini or Entity Data or PwC or smaller ones like Myborn Wolf. There's so many great consultants that have already done that a number of times. They will help you finding and defining a modular architecture that is not a dead-end road, but actually is state-of-the-art and allows you to scale. The worst thing that you can happen is doing it alone and coming up with a do-it-yourself approach that doesn't scale or that has risk that you just don't know yet. Step number 4, start with a single use case, no matter which it is. Prove your architecture, test your methodology, improve your collaboration. Every single use case will provide some business value, but more especially it will provide experience about this new organizational setup. And if you're comfortable with all of this, 1, 2, 3, 4, start to roll out from site to site, different use cases, whatever you want. But this is the road to success. And this is all from me. I hope this was a valuable presentation for all of you. I think we have 5 more minutes for your questions. And as I said, I strongly believe real smart factories are designed and operated like software. And if you want, we are happy to help you on your way.
Thank you very much, Peter. So we do already have some questions coming in, and I just published one concerning your last thoughts you said from your slides. You said start with one use case. So one question was, do I need loads of use cases before I see a positive ROI?
That's an excellent question. The big question is, what exactly is an ROI? I think the ROI question is one of the problems. I don't say there's no ROI at all, but people often underestimate the cost of not acting. So the cost of inactivity can be pretty large, because if you look at ROI only for every single use case, you risk increasing the problem that I shared in the beginning, and the cost of rolling back is just very high. So this is the first answer. Increasing your technical debt is the biggest risk that you can face. And the next thing is, of course, if I would always choose a use case that immediately pays back. The hard thing is sometimes to find this one, because again, knowing the unknowns, do you actually know where your biggest inefficiency is? So when I'm asked where I would start, I would usually start with a use case that is not expensive to implement. For example, really machine monitoring. You would be surprised how much you can save already by just knowing live and always which machine is currently running and which not. That sounds so trivial, but most factories don't know that. But if you have this data available, you can easily spot problem hotspots. You can spot sometimes even process inefficiency. You can improve how the night shift works. You can improve your maintenance processes. So with very low investment, you can already get a high payback. So if you have the right starting use case, your ROI will be pretty quick. But still, and this is the important thing, if you start with a minimal technology stack to only solve this first use case without thinking ahead, then you are in a dead-end road again. So this is a balance that you have to find.
Thank you. So next one that I published here, it's a quite longer one. What role do established or emerging architecture standards such like RAMI 4.0, ISA 95, OPC-UA play in successful projects? Where is it worthwhile to take an individual company-specific approach? Your thoughts, Peter?
I have to think about that one for a second. First of all, I would have a close look at all of these best practices or standards. The problem about standards always appears when there are many. So you, of course, have to consolidate that into your company standard, and you have to have a very clear opinion and position about that. OPC-UA clearly is a winner when it comes to machine communication. And if you are strong on your OPC-UA technology stack, that is of advantage because more and more machines that you can purchase off the market, no matter if it's bespoke machines or off the shelf, just will support OPC-UA. Still, OPC-UA is just the communication with a machine. It does not answer how you manage data in the whole factory across all the lines and so on. So for this, the unified namespace concept is much more flexible, much more scalable, and you really need a strong combination of all of this. OPC-UA is a foundation on the shop floor. Then you usually have a unified namespace as a platform in the middle. And then when you look at the different use cases, really on the application level, I think I strongly believe things are moving currently a lot. So you need more flexibility the higher you come in the architecture, because AI will change the game of industry software and industry applications and so on in the next 5 years. That's for sure. You have to have a strong foundation below that.
And another quick one with a quick answer, picking up on the ROI question or ROI topic beforehand. How do I actually hit ROI when rolling out a data hub like Connectware?
I wouldn't say the data hub itself is the origin of an ROI. It's more the digital transformation as a whole. So in the end, and this must be the goal of digital transformation, is an overall improvement, right? If your factory is not 10 times more efficient, or 10 times more would be great, at least 10, 15% more efficient after digital transformation compared to before, then digital transformation wouldn't have a point, right? So look at your yearly revenue, look at your costs, look at your EBITDA, set a goal, and this must be achievable, and then derive the investment budget from there. And the investment involves a lot of things. It involves a cloud strategy, it involves connectivity, it involves hiring probably new people with new skills. And this is the investment you have to do into a smart factory. And I guarantee you this will pay off, both in efficiency and margin, but also in competitiveness, because all of your competitors are already doing that.
You just mentioned investments. So we do have actually a question regarding those investments. Which arguments and KPIs typically convince top management and board members to approve investments in standardized OT/IT infrastructure, even when initial costs seem high? So you mentioned before, the CEO needs to align everything, CIO, COO need to speak one language, but when it comes to investments, what are the actual convincing messages here?
Yeah, also quite simple. Just look at, so the most convincing argument is look back 3-4 years and build the sum of all IT customization projects that you have done. And this will be a surprisingly high number, because IT customization and doing it again and again, this is a high cost that nobody ever looks at from the controlling, because it's always project by project. If you build a sum, you will be pretty surprised how high that is and what your wiggle room is to not increase investments. I'm not talking about increasing CapEx, maybe just redirecting it to something that's more sustainable.
And one question, when we talk about global standardization, how do you manage local customization, especially in industries with legacy systems?
That's a good one. That's a good one. Big problem we often have, and we have customers with 40, 50, sometimes 100 factories. These factories are pretty autonomous, usually, and they don't really like to be overruled by a global IT. Group IT is usually the enemy, yeah? It's the evil guys that want to take us control. So we have to find the right balance, and this is a mindset question. Group IT and all capabilities, shared services basically that you provide group-wide, must have a notion of we want to enable the local autonomy. So you need to provide shared services from your group IT that allows every single site to follow their individual agenda, because they will have different priorities, as I said in the beginning, depending on the automation grade, depending on the regionality, depending on the types of production. You will have very different priorities. Often you still find surprisingly many use cases that can be just globally rolled out. Energy management is one of that. But you need to really make sure that the individual priorities are considered. Every single production manager must be able to follow his agenda. Otherwise, they will block you. Otherwise, they will not comply with the overall strategy. So this is a buy-in question. On the other hand, you probably will not build a whole IT and data science team for every single site. So these are the services that you can provide centrally, and you need to find a good collaboration mode in order to provide these services in a very efficient way, and to find a collaboration between group IT and every single site, especially in organizations that have a high complexity, and there are a lot of these.
Okay, thank you. I think that's it from the question side. Are there any further questions? I didn't see any further ones. So thank you again, Peter, for being here today and presenting this topic to everybody. And you will get, of course, or everybody will get the recording afterwards from us, and also the slides. If you need any further information that we just talked about here, any in-depth, feel free to reach out to us. We are happy to provide you with a live demonstration with our Cybus Connectware. And we also would like to have your feedback once you leave, or you will be redirected to a next site, hopefully asking some questions, what you thought about this, and if you would need any further information about this. So I think this is it. The one that said going to Scotland, I think having a nice whiskey there, hopefully. And for those of you going north, chilly summer probably this time, and going south, it's a hot summer this time. And hope everybody returns safe, and see you at the second half of the year, everybody.
Thanks a lot.
Bye-bye.
Thanks,